I'll check 1 minute, sir.
Okay, no problem. I am discussing it. Okay. So before the assignment, I will
Yes.
tell you about the integration. Sorry, differentiation and integration. Okay.
Okay, sir.
Because you have not much idea about differentiation and all that. Okay. So let's.
No, sir, I didn't get the assignment, sir. It's not here.
On the portal, there is no assignment.
No, sir, the last assignment was 24th June. After that,
Okay,
nothing is
okay,
there.
okay. Leave that. Leave that. So, differentiation. So let's see what is differentiation. Okay.
Yes, sir.
Suppose I am writing y equal to 3, not 3. X to the power 5. This is x. And differentiation means simply you can say dy divided by dx.
Yes, sir.
Differentiation. So if I want to calculate, I want to differentiate. This is question number 1. Question number 1. So question is differentiate x to the power 5. So it means I have to calculate dy by dx, dy by dx, and dy by dx is simply what I have done. This power will come here, and we will minus, like this is x to the power 5, right here x to the power 4. Finish.
That's it.
Let's move to another question. Suppose I am writing y equal to x to the power 6, and I want to calculate dy by dx.
Okay, 6 into x to the power 5.
Very good. Dy by dx.
5 by dx is equal to
6 into x
to x to the power 5.
Fine.
Yes, sir.
Good. If y is equal to 5x to the power 6 and I want to calculate dy by dx. So what will you do? You should multiply this 6 with this 5. Okay. Now you should multiply with this 6 with this 5. This will be 30. And x to the power 6 will become x to the power 5.
Okay.
Simple, no?
Yes.
Not a problem. This is the thing. And now another question. Acha, one thing. Can I write 1 by x like x to the power minus 1?
Yes.
And again I can write x square
as x to the power minus 2.
And if I want to write x, I write x to the power 100. What should I write? X to the power minus 100?
Minus 100.
Okay, very good. Suppose there is a question, and if I want to calculate the y is given as 1 upon x square, and I want to calculate dy by dx. So let's how I will do that. I can write y as x to the power minus 2. Okay. This time what you will do, when you will find dy by dx, you will, at that time what you are doing, you are multiplying this 6. Nah? So here
Yes,
is
sir.
6. Now here is minus 2.
Yeah.
So you have to write here first minus 2. And
Minus
after
2.
that, what you should
X raised to
do is,
minus 1.
and x raised to the power minus 2 and subtract minus 1 from this. So this will
Yes.
be minus 2
Minus 3.
x to the power minus 3.
Minus 3.
Earlier, see what happened. So answer is minus 2 into x to the power minus 3, and I can write x to the power minus 3 as like this,
X,
no?
yeah, 3.
This is the
Okay.
answer. And earlier what happened? Let's see. Earlier what happened? I have written here y is equal to x to the power 5. So earlier what happened? Y is equal to dy by dx is equal to, earlier what happened? This 5 came here, and what happened? X to the power 5. Power we have to, I was subtracting minus 1 from here. That's why I have got the answer x to the power 4. So here also I am doing the same thing. Here also I am doing the same thing. This term minus 2, this minus 2 will come here, and x to the power minus 2, and so it means that in differentiation what we will do? We will subtract the power of something with minus 1. Simple. Okay. So now let's see. Y equal to 1 upon, sorry, this is 2 upon x to the power 5, and I want to find dy by dx. So let's see how I will do this. I will take this y as 2 upon x to the power 5, and I can write this 2x to the power minus 5.
Yes, sir.
And now when I will write dy by dx, what will happen? I will multiply this minus 5 with 2. This will be minus
2,
10.
yes, minus 10.
Minus 10, and what
X
will
raised to
happen now?
minus 6.
Very good. Minus 5 and minus 5. Minus 10 into x to the power minus 6. This is enough. This is the end of differentiation for you. If you have understood these things, think from here to here, this is okay.
Okay, so can I write this?
Okay, you can write, of course. Fine now?
Yes, sir.
Understood now?
Yes.
Very easy thing. Just you have to subtract the power in differentiation.
Yes, sir.
Whether it is partial differentiation or like this differentiation, full differentiation.
Yes, sir.
Harsh, you are from where?
In India, I'm from Pune, sir.
Right now you are
I'm in Saudi Arabia, sir.
in Saudi Arabia. Okay, fine. Please note it down. Understood now these concepts? Very
Yes, sir,
easy.
yes. Yes.
Remember this also.
So you can scroll down.
Harsh completed?
So just answer.
Okay, fine.
Done, sir, done.
So this is all about differentiation. And I am giving you one question and please solve this question. And take your time also. Do this question carefully. Dy by dx. Please find the answer. And take it easy, okay?
Okay, sir.
Give me a minute and you should try. Harsh, have you completed?
Yes, sir.
What is your answer?
Sir, I'm getting 612 x raised to minus 103.
Okay. Now I am solving. Please match your answer. Okay.
Yes, sir.
Okay. Is this your answer or not?
Yes, sir.
Okay, very good. Now it means that you have understood the differentiation. Now let's move to our topic. We were doing this. We were doing this. I have told you now this thing. Electric
Yes,
field is
sir.
minus dV by dr.
Yes, sir. Yes,
And
sir.
how these things are coming now. You know the differentiation. I have told you this question also.
Yes.
Now, now I am starting from here. So let's see, Harsh. This is the direction of electric field.
Yes, sir.
This is the direction of electric field, and I have told you in the direction of electric field.
Potential decreases.
Very good. In direction of electric field, potential
Decreases.
decreases. And before that, we have one question. Like electric field is given as E is equal to 5 y square, and find the electric field in y. And we have the formula for this. Sorry. This should be B. Potential is given in terms of y.
Yes, sir.
We have three axes now. Y axis,
X
X
axis,
axis, and Z axis.
Z axis.
So means potential is given in terms of y, means the potential is changing in y direction only.
X and Z
Okay.
are constant.
Okay, and x is constant means electric field in x direction is 0.
0. Yes, sir.
There will be 0, and z is also 0.
Be 0.
Okay. Now, electric field, what is the formula of electric field in y direction?
Yeah. Minus del.
Minus dvy, dy.
Dvy, right?
Okay. dvy.
Sir, it would be 10 raised to power 1. 10 y raised to 1. Yeah. 10 into y raised to power 1.
Now understood, na?
Yes, sir.
If you find these types of question in your examination, you can solve, na? Okay.
Yes, sir.
Okay, good. So now I am moving on a topic. And what about this question?
I understood, sir. Last class only you did.
But there, what should you do when you differentiate these types of question? You should kept y and z as constant.
Constant, yes.
Okay.
Yes.
No problem. Equipotential surfaces. This is our topic. You can see from the name here, equi means same, potential means potential, same potential. So equipotential surfaces are the surfaces on which the potential of every point is same. surfaces on which the potential of every point is same. Like this, suppose this is a potential, equipotential surface. This is point A and this is point B and this is point C. A, B and C. So it means that BA equal to VB equal to VC, and what is this surface? This is equipotential surface. There is one example of this surface, equipotential surface, like conducting sphere having point charge at the center. So we have a conducting sphere, okay. This is the sphere and this is conducting sphere. What do you mean by conducting sphere, Harsh?
Sir, a sphere,
Okay.
a sphere which conducts electricity.
Fine. So there is one another property of conducting sphere. Conducting sphere, when you give the charge, when you give the charge to the conductor, any conductor, whether it is a sphere or whether it is cube, the charge will always appear on the surface. Charge will move towards the surface. This is the property of conductor. So what will happen in this case? This is radius r, and now we have a formula. If I want to calculate B inside, potential inside or potentials on the surface, the formula will be K and this charge on the surface Q and divided by R. So Harsh, can you please tell me this potential will be constant or not? This is constant because why
the
this is constant?
will be constant or not? Yeah, constant, right?
Constant because this K is constant. K is not changing.
Yes,
This Q will not change. And this R will also not change. Means this whole thing will not change. Means on the surface, if you calculate the potential at any point, like if you want to calculate the potential here, here, here on the surface, you will use this formula, same formula, na? So it means VA is equal to VB is equal to VC is equal to VD. Okay, ठीक है? Okay. Have you understood, Harsh?
yes, sir.
Okay. Now write the heading properties of potential surface. we know the first property. Potential is same at every point of equipotential surface. Second thing is, this is the important property. Electric field is always perpendicular to the equipotential surface. Suppose this is an equipotential surface. So electric field will be like this. This will make an angle of 90 degree
90 degrees.
with this side. So this is equipotential surface.
Yes, sir. It always makes an angle of 90 degrees.
No. Another property.
It's 0, right?
Good. So work done in carrying a charge from one position to another on equipotential surface is 0. Let's see how. Suppose this
W is equal to Q,
हाँ,
WP minus
हाँ,
W, VA,
हाँ,
sorry, VP minus VA.
सही बात है. You are right. Suppose this is a point A and this is another point B, and I am taking a charge from A to B, taking a charge Q, from A to B, and I want to calculate the value of work done, and we have the formula of work done. Charge into change in potential. Delta V is change in potential.
Yes, sir.
And Q is the charge. What is change in potential? Final potential.
Final potential minus initial potential.
And this is the equipotential surface, means VA equal to VB. This will be 0.
Sir.
So I have proved now work done on the equipotential surfaces to carrying a charge is equal to 0. Write it down.
Sir, can I scroll up and write all the properties, sir? So then
Right?
one more, right? Equipotential surfaces can never intersect each other.
What?
Equipotential surface can never intersect each other.
Okay, that's fine. First write this.
Okay. I'm not done. That's what I was asking.
There are many things about equipotential surfaces. Can electric field lines intersect each other?
Electric field, no, sir, they can't. It will show two directions then on a particular point.
Good. Should I scroll down?
So 1 minute.
Okay, okay. You can take your time. That's not a problem. Okay.
Sir, you can scroll down, sir.
Written?
1 minute, sir, 1 minute.
Okay.
Done, sir.
Now let's move to the next property. In region of stronger field, you can say electric field. Surfaces means equipotential surfaces. Surfaces are closed. Closed means like this. Okay. And in region of peak electric field, the surfaces are far apart. So we have a formula na. E is inversely proportional to 1 by dr. What is dr? Dr the separation between the
Difference of
surfaces. Okay.
Yes.
Fine. These are equipotential surfaces, and suppose this for an example, this have a potential of 5 volt, this have a potential of 8 volt, and this is 11 volt. Okay.
Yes, sir.
And Here is an electric field which is increasing in this direction. I can draw like this. This is an electric field
Increasing.
increasing. This is surface 1. I am supposing this is surface 2 and this is surface 3. So increasing means when in between these two surfaces, if I am supposing the electric field is E1, and suppose I am supposing the electric field between these two surfaces as E2. So means increasing means E2 will be greater than E1, na?
Yes, sir.
Means increasing is like. So Harsh, now please tell me what is the relation between D1 and D2?
D1 and D2.
Which one is
Relation
greater?
between D1 and D2.
Will D1 be greater or D2 be greater?
Like,
Let's see.
which one? D1 is a greater, sir?
How? Why?
Electric field is moving in the direction potential.
Let's see. You are right. Like electric field E1, okay,
Yes, sir.
is directly proportional to 1 upon D1,
Yes.
and E2, sorry, directly not inversely proportional. 1 upon D2.
Yes, sir.
This is E2. Now let's see here. E2 is greater.
Yes,
Means
sir.
D2. If E2 is increasing, E2 is more, then D2 will be less. E1 is, which one is greater? E2 is greater now. If E2 is greater,
Yes, sir.
this D2 should be less, means
Less.
this D1 should be greater than D2.
Okay, sir.
Simply you can say electric field, if electric field is more, distance is less. Here electric field more, distance less. Means D1 is greater than D2.
Sir, that's what I was going to say, but I thought it was wrong.
Okay. Now have you understood how this is coming? This is, I am driving
Yes,
this from formula.
Yes, sir.
Here, this is a region of weak electric field.
Yes, sir.
Region of weak electric field means the separation will be larger according to this definition, according to this point. Here the electric field is more, so the separation should be less.
Less.
Noted?
Yes, so one more. Done, sir.
Done. Okay. Fourth is no two equipotential surfaces can intersect each other. Let's see how. Suppose this is one equipotential surface. This is one equipotential surface. Okay, and this is another equipotential surface. Fine. And these surfaces are meeting like this. Means intersecting like this. Okay, Harsh, have you got it?
Yes, sir.
I think this diagram is not that correct that I want to make. So these are two equipotential surfaces. And suppose these two equipotential surfaces are intersecting. Suppose. Intersecting like this on this line. On this line. Okay. So if you take a point here, take a point here. Due to surface 1, this is surface 1 and this is surface 2. The electric field should be perpendicular to this surface 1. Harsh, am I right or not?
So can you repeat the question again?
What?
Can you repeat what you said? Like my net is not very good today.
Okay, no problem. These are two equipotential surfaces.
Yes, sir.
And these are intersecting with each other.
Yes, sir.
Now we have to prove why they cannot intersect each other.
Okay.
Now look at this surface 1. Due to this surface 1, the electric field, as I have already told you, the electric field is perpendicular to this surface. Okay.
Yes, sir.
So means the direction of electric field should be like this. And again, this, now look at this surface 2. And this surface 2, this point is also on this surface 2. And the direction of electric field should be perpendicular to this surface 2.
Yes, sir.
So means direction should be like this, perpendicular. So there are two directions at a point of electric field. That is not possible. That's why we can say no two equipotential surfaces can intersect. At
Yes,
because यहाँ पे हम लिख सकते हैं because at the point of intersection. At the point of intersection, there will be two direction of electric field. There will be two directions of electric field, and which is not possible. Like electric field line can never intersect each other. With why? Because at that point there will be two directions of electric field, and which is not possible. Same is the case here. Okay.
So I'll write this.
You have written?
No, sir, I'll write one more.
You have written this?
Yeah.
Now please write this.
Done, sir.
Done, no? Okay. So these are the properties, and there are some additional points that I am going to tell you. Like if I am saying electric field is like this. This is the electric field, and this electric field is constant along x-axis. This is x-axis, and this is
Yes, sir.
y-axis. So here the electric field is constant along x-axis. So we know that equipotential surfaces are perpendicular to electric field. This is one equipotential surface. This is another. Okay, no problem. We can make ourselves. Harsh, are you taking tea or water?
Sir, water.
Water.
Yeah. I don't drink tea, sir.
What?
I don't drink tea.
So these equipotential surfaces will be perpendicular to this electric field. like this.
Yes, sir.
This is distance d1 and this is distance d2. Now Harsh, what is the relation between d1 and d2? d1 is greater than d2 or d2 is equal to d1 or d2 is less than d2? d1. What will be?
Sir, D1 is less,
Equal.
right? Yeah.
Equal. Why? Because
Yeah. It's not given. The thing is wrong. Yeah. The potential is
dr
not
na.
given.
So here
Yeah.
E is same, means dr also same.
Yes, sir.
So we can say d1 equal to d2.
Okay, sir.
There is one more point. Suppose electric field is like this. This is electric field and this is increasing along y-axis. Increasing along y-axis. So we know that the equipotential surfaces are perpendicular like this. And this is d1 and this is d2. Suppose at this point the electric field is E1 and at this point the electric field is E2. So will E1, which one will be greater, E1 or E2?
It will be equal, right? Oh no, wait.
E2
Increasing
is
along
greater than
y-axis. No. Increasing
E2.
along y, yeah, D2 is greater than.
Increasing along y-axis. When we move
Yeah.
along y-axis, means the electric field will increase. Electric field is increasing means this distance will decrease. Distance
Yes,
will be
sir.
so I can say
E2 is greater than.
D1 is greater than D2.
Yes, sir.
That is simple. And we have a formula like we have a relation here. So please note it down.
So just hold up 1 minute. Oh yeah. You can return, sir. Sir, I can't see the one which is up.
Okay, 1 minute. Now it's okay.
Yes, sir. Yes. Thank you, sir. So just hold on.
Okay.
Sir.
Fine. Done.
No, sir. One. Sir, what was I saying? Sir, like I had my unit test the past week. So can you just solve the paper next class?
What?
Or if you,
What?
I actually had my unit test last week.
Yeah.
Unit test in school. So
Yeah.
can you solve the paper?
Oh, that you should do by yourself. Try to take the help from the book.
No, sir. I attempted every question in that. But I'm just asking, is that correct?
Okay, no problem. Right now, so we have to do the syllabus, but in group you can send me. Okay, I will ask this by the employees. Okay,
Okay, sir.
maybe in the next class.
Yeah, next class. I was just asking for the next class only. Because it was the only paper which was easy. That's it.
So can you share your screen and do
Sir,
you have that?
I'll send it on WhatsApp of the coaching thing class. Yeah.
Okay, you can send me on the WhatsApp. Okay, you are on the group now. You have my number and you can have any group by the
I
company or
don't.
by the app.
Yeah, I have of the coaching number. I have.
Okay, so you can send them. They will send me. Okay, and we will
Oh,
discuss those papers in the next class.
sir, it's only it's 10 questions. That's it.
Okay.
Just are done.
Done now? So now we'll draw the equipotential surfaces. For point charge, suppose this is a point charge. Okay.
Yes, sir.
And now you can imagine what is the potential at any point due to this point charge. KQ by R.
Yes, sir. KQ by R.
K is same, charge is same. If R is same,
R is distance depends.
R is the distance. So now
Yes.
you can imagine a circle. You can imagine a sphere of radius R. That will be the equipotential surface. Mm. Like the equipotential surfaces for a point charge will be a sphere around it, will be concentric sphere. Please consider these as spheres, okay?
Yes, sir.
Concentric sphere, and the direction of electric field will be like this, na? We have
Yes,
already.
sir.
For a point charge, the electric field is like this. Electric field lines.
Yes, sir.
I am not drawing all the lines, but okay. So means lines will be like this and this and this. Okay, in 3-dimensional space. Okay, and these lines, electric field lines, I have already told you, is perpendicular to equipotential surface. Today I will end this class at 8:42. Okay.
42. Like in 4 minutes.
Yeah.
Okay, sir.
And in the next class, I will discuss about the equipotential surfaces due to a dipole or due to two positive charges. Please note it down. And
Okay, sir.
before that, I want to ask you some questions. Note it down.
Yes, sir.
Okay.
Sir, 1 minute. So scroll down, sir. You can scroll down, sir. 1 minute. Yes, sir. Just 1 minute.
Okay. Now let's start. So, Harsh, you have studied the electrostatics, charges and field. Have you studied?
Yes, sir. The
Okay.
first lesson.
Okay, no problem. So, please tell me what is charge.
What is charge?
Yeah.
Like definition of charge.
You can tell anything about charge.
Charge.
If someone is asking you about the charge, then
It is a particle which contains both protons and electrons, right?
Charge is a particle. You are saying charge is a particle. Or
which contains electrons and protons.
Charge is not charge. How can you say charge is a particle? Electron is a particle. Proton is a particle. Charge is not a particle. Charge is a property of particle. So let's see. Charge is the intrinsic property of matter. Simple.
Yes. Okay. Charge
Charge
is intrinsic property. Property
of matter.
Matter.
And for
Yes.
example, you can say like electron. Electron have negative charge. And what is the
Negative
charge
charge.
of
Protons have positive.
What is the charge on electron? Harsh?
Like the value.
The value. And please tell me what
1.6 into 10 raised to
1.6 into 10 to the power. Please don't see here and
minus
there.
19. Minus 19.
Minus 19. And what is the unit of charge?
Coulomb.
Very good. So that's
it's correct, right?
Yeah, it's correct. And suppose if I am giving you a conducting sphere.
Okay.
And the charge on the surface of that conducting sphere is Q.
Okay.
Now you have to find out the electric field inside that conductor. What is the value? Electric field inside the conducting sphere having charge Q. Please revise your notes. Actually, I have already told you many times that in a conductor there is no electric field.
Yeah.
Okay.
Yes.
So whatever is the conductor, whatever is the shape, no matter. The electric
conductor has no electric field.
Conductor has no electric field, you cannot say. You can say inside the conductor there is no electric field.
Yeah, like inside the conductor there is no electric field.
On the surface there can be electric field. And please tell me one thing more. This is the last question for you. What is electric field?
It is a region or space around a charge or a system of charges where force, repulsion, or attraction is present.
Okay, and what is the expression for electric field? If suppose if I
E is equal to F by Q.
Okay, very good.
If and suppose it is unit
suppose I am giving a point charge and I am saying please calculate the electric field at this point P.
Yes, sir.
So what is the value of electric field? I am only asking magnitude.
At point P.
At point P. Just simply KQ by R square.
R square, yes.
And if I want to find the potential at point P,
Vp is equal to
KQ by
R.
Okay, and if I have put a charge Q1 here, then please tell me what is the force between these two, Q and Q1.
Second, repeat the question.
There are two charges separated by Q
yeah.
and Q1 are the two charges and separated by a distance R, and I am asking what is the force between these two charges.
Force.
Coulomb's law.
Sorry, Q1 Q2 by R 4 pi epsilon 0 R
K,
square.
K,
yeah, K.
Q1 Q2 by R square.
R square. So it can also be written as Q1 Q2 by 4 pi epsilon 0 R square, right?
Okay, you can write value K is equal to 1 upon
9 into 10 raised to the power 9.
Epsilon naught 9 into
10 raised to
the power 9. This is only for air or vacuum.
Okay.
Okay.
So yes, sir, I told the answer.
Okay, no problem. That is fine. Means you have studied. Please try to revise your note. And can you tell me what is Gauss law?
Gauss's law. The total electric flux coming out of a closed surface is 1 by epsilon times the total charge enclosed in the surface.
Hey, what are you saying?
The total electric flux coming out of a surface is 1 by epsilon time the total charge enclosed in the surface.
Very good, very good.
This
is what the Gauss law.
Yeah. I guess it is Gauss law.
Okay. And what is electric dipole?
Sir, it is a pair of two opposite charges for a very short distance.
Very good.
and it is dipole moment is the measurement of electric dipole denoted by P.
Suppose this is two charges,
Yes,
and
sir.
if I want to calculate, this is a negative charge. Okay, sorry. This is charge minus Q and this is charge plus Q. Okay.
Yes, sir.
And what is the potential at point P?
Potential at point P.
This is the equatorial position, and I
Yes,
have
sir.
told you at the equatorial position potential is 0.
Yes, sir.
Okay. Okay. What is the name? Harsh. Now you can leave, and please, humble request, try to revise your notes. Okay.
Yes,
And
sir.
you have told me that you want to solve your paper.
Yeah.
By me. So, how that paper will